Hello, my name is David Calhoun, and my informative speech is the human brain and how memory works. Imagine trying to recall the happiest moment of your life. Maybe it's a childhood birthday party, graduating from high school, going to prom, or maybe even the birth of a child. Now consider how your brain instantly retrieved that memory. It's not just a simple replay. Your brain is performing a very complex process that scientists are still trying to work and understand today. Memory is not just about remembering facts. It shapes who we are, influences our decisions, and it impacts how we navigate through the world. Today, I will explain how the brain encodes information through sensory input, how memory is stored in short-term and long-term systems, and how retrieval allows us to access stored information. To begin, let's explore the first step in memory formation, encoding. The brain encodes information through sensory input. Encoding, defined in the article Memory, Neurobiological Mechanisms and Assessments, as the process of converting sensory information into a format that the brain can store. Different types of sensory input activate specific regions of our brain. Visual information is processed in the occipital lobe. Auditory information is processed in the temporal lobe. And touch, temperature, and pain are encoded in the somatosensory cortex within the parietal lobe. There's a role of the hippocampus in encoding. The hippocampus, located in the medial temporal lobe, plays a critical role in consolidating new memories. It acts as the central hub that links different sensory inputs into coherent experiences. And according to the National Institute of Health, any damage to the hippocampus area results in difficulty forming new memories. Now that we have a little bit of understanding about encoding, let's move on to how the brain stores memory. It stores it two ways, short-term and long-term. Short-term memory, also called your working memory, holds information for immediate use. An example is like having a math problem. Your prefrontal cortex temporarily holds the numbers and the calculations before discarding it or transferring it to long-term memory. Long-term memory, also known as LTM, involves transferring information to permanent storage, a process facilitated by the hippocampus and distributed across the cerebral cortex. Declarative memory and procedural memory. Declarative memory is memory of facts and events and is stored in the temporal and the parietal lobes. Your procedural memory is like skills of riding a bike or swimming. Those are stored in the cerebellum and the basal ganglia. Then there's the role in sleep in memory consolidation. Memory consolidation is the process of stabilizing memory over time. And according to the article in Nature, Engram, Neurons Encoding, Consolidation, Retrieval, and Forgetting, scientists have found that sleep allows the hippocampus to transfer information to the cortex for long-term storage. Now that we've explored storage, let's examine how the brain retrieves it. Memory retrieval allows us access to stored information, and this process is reconstructing memory from different brain regions, often relying on cues such as emotions and context. The prefrontal cortex helps focus attention during retrieval. The hippocampus is critical for recalling specific events. The amygdala tags emotional memories, which is why traumatic or highly emotional events are much easier for us to recall. Challenges in memory retrieval consist of interference, which memories can compete, decay over the length of time, and physical damage, injuries to the hippocampus. Now that we've explored how the brain processes memory, let's conclude by reviewing what we've learned. The brain encodes sensory input, how memories are stored in short and long-term systems, and how memory retrieval helps us recall information and experiences. The brain's ability to encode, store, and retrieve demonstrates its incredible complexity. Memory is not just about remembering facts. It shapes our identity, our decisions, and our daily interactions. So the next time you recall a cherished moment, think about the millions of neurons working together in that brain to bring forth that memory. The human brain is truly remarkable. Every time memory is used, it's a statement to it's a testament to its power.